Okay, I am now making a follow-up video for my general probability rules because in the previous video we talked about rules like the multiplication rule and the addition rule, but in the addition rule it only worked when events were disjoint, and in the multiplication rule it only worked when the events were independent. So we introduced some general rules. So we have the general addition rule because we want this to work no matter what. And the general addition rule says that if we're looking for the probability of P of A or B, then we would take P of A, add P of B, and subtract the overlap. So this would be for one or the other or both, right? And we want to take care of the fact that if these events are not disjoint and they do have overlap, that we subtract it out. And then I want to just say that note, if A and B are disjoint, then the probability of A and B, remember disjoint means they can't happen at the same time, so there is no overlap. So we would just not subtract anything, and we'd be back at the regular addition rule. Okay, now on to conditional probability. Okay, a conditional probability starts with an event occurring prior to another. So it's written in this language of the probability of A given B. So B already happened, right? So we would write that like this, A given B, where this line right here means given. And we would compute this by saying, well, we're saying that they're now both happening. So they're both happening now. But we want to divide by the probability of the event that already occurred. So we always want to divide by the probability of the event after the given statement. So I'm going to box this one up because this one's really important. We use this all the time. And then one more before I go to the next slide, because I think this is only 4 rules that I want to talk about. This is the general multiplication rule. And remember that addition was for the word or, right? So the general multiplication rule would be for the word and. Okay, and the general multiplication rule says that it doesn't matter if we talk about P of A and B and them being independent. We could start with the probability of event A, and then we could multiply by the probability of event B given that A already happened. Okay, so this multiplication rule works whether or not my events are independent. But then there's this huge important note that I want to make, and I'm going to do it in blue or something. Note. Right? If A and B are independent, then the probability of B given A just equals the probability of B. So we're back at this original formula that we had in our first set of rules for probability. But if A and B are independent, then A has no impact on B, and it does not matter if A happens first. We would just get the same exact probability here. So on my next slide, there's only one more note I want to make, and it's to show two events are or are not independent, right? So we want to show whether or not they are independent. So it's are A and B independent? Show that P of B given A just equals the probability of B, right? This tells me that A has no impact on B, right? So if two events are independent, then the probability of one does not impact the other. And we very often are asked to show independence. So we are very often asked to actually show this, right? And so we will be doing this particular formula in class and illustrating that together. But that's it for my extra probability formulas, and we will continue to do examples of these in class and apply them all, because it was a lot, I know.